Only sound, Martin, Arun-san, Weston, Topiker, Jancy, Kumar, Anil, Yahweh, V. Okay. Anyone whose name is not first? Okay. So we have 5 teams. So any question regarding to the project? So I think some of you guys do not have any idea yet. So but after today's lecture and the following the exercise lab, you will have the more idea. Anyway, that's the limitation of the summer course. You should admit the time constraint, so which means you need to work at least double times than the normal semester. So even though due date for the first proposal is June 17th, it's after midterm, but you'd better submit the proposal to get the more idea or comment from me, and you can have the more time. So believe it or not, next week, Thursday, we will have the midterm exam. Okay? So it's already half of the semester is completed. The next week, so we will have the midterm exam next week. Regarding to the midterm exam, I will give the little bit idea about the midterm exam Thursday during the exercise lesson. Miss the exercise next week. So those who already discussed about the project topic, you need to find more references from the website or the internet or the books, paper. Okay. Then whether you can download the data, that's very, very important, unlike the other project. Because if you do not have any data, even though you have a very nice idea for programming or big data analytics, you cannot test, you cannot implement it. So these are the signs you should have. So just 10 or the 20 rows or record, I don't think that works for your project. So these number size should be the millions of the record with several hundred byte data. Gigabyte data is much better. Okay. So after you find the data set, there are some benchmarking data set that you can download from websites. I try to introduce one of them, but there are many in the website depending on the data. So also some of the government websites provide the data set like the census data or the weather data and many other. Actually, one of the starting point of the big data system and big data research are from the President Obama's address several years ago. So at the time, the Obama government would try to fund money for big data from the government data sources. So US government hold a huge amount of the data they try to open to the public. So if somebody wants to handle or manage such a big data, so US government would like to give the money to them. So actually that initiates the big data research as well as the industry market to boom. Okay. So, and last time you had exercise lab for the first MapReduce programming, which is a word count. So it's a good idea to check the source code of words again. Then see word count is like the hello word program in other program languages. When you learn the new program language, probably you print out the hello word. Okay? So which means that this is a very simple program, but it's kind of a template. So it's just a good starting point to implement your own project for the MapReduce programming. At least you should understand the word count program. Okay, it consists of the three-part: driver, mapper, and reducer. Driver is kind of the coordinating of your program. Okay, and then followed by the mapper. Mapper, before we briefly overview of the review of the map reduce programming. So we have client. Client computer can be anywhere as long as they are connected to the master node. So there are two types of the node in the Hadoop system. One is the master, another one is the slave. So master node is the naming node. There are secondary naming node, which is not backup of the naming node, but it's a housekeeping job of this one. So which means the naming node is a single point of failure. So which is very important. It's coordinating all the Hadoop system. Okay. Then we have the data node. 1, 2, 3, as many as possible. Okay. They are definitely connected. Usually client request the job. So each node should have one. There are two core components of the Hadoop system. One is HDFS, and another one is map reduce system. These two are core components of the Hadoop system. So each node should have the same HDFS file system and map reduce system. HDFS, map reduce, HDFS, map reduce. So in HDFS, what is HDFS? It's a file system for distributed file. So when the client requests for writing a file, it will. So first, the file should be stored at the client local file system, and this file will be segmented by the block. Each block has 64 or the 128 megabytes. It's a big, much bigger than other DBMS or operating system, which is usually several K. Okay, sometimes 512 bytes, but it's a much bigger, 64 megabytes. After request naming node has all the metadata, which node has which block, and so each block will be copied to the HDFS. Okay, so each file, each data node has the block 1, block 2, block 3. Block 1 will be copied to at least 3 copies of them along the node. Okay, and block 2 is also 3 copies, and block 3 has the 3 copies. Okay, then this is the very, very high level overview of the HDFS Hadoop system. So then we'd like to use this HDFS Hadoop I/O for map reduce programming, map reduce system. Actually, map reduce is not only for Hadoop system, okay? But the Hadoop, after the Google developed the Google file system, they need the new program language. Like when you implement the distributed file system, you can use different program languages like the Open MPI. Okay, so MPI is message passing interface. It can make the program parallelized. But at the time, so as we discussed, it's very, very difficult to code the parallel programming or even manage the parallel programming. Like what about the partial failure? It's very tough. So, but for map reduce programming, they developed the map reduce version 1, 2, something like that, that can handle resource or the Hadoop system. Okay, so very well matched. But actually, the map reduce is not only for the Hadoop, but they are working together. So to utilize suppose that we have a file on the Hadoop system, HDFS. So we try to use such a file for the programming to analyze the data. For example, we try to count the word for and something like that. So this is the document. So they are in the file, okay, and stored in this file. They are distributed under header file system. We try to count the word, like how many are, so 2, how many are next, and 1 are 1, and so on, something like that. We want to get such a result. It's called the word count. Okay, it's our goal to process such a distributed file. So let's say this is a full.txt file. So full.txt file is already distributed on the HDFS. So at least each block has 3 copies. So for this one, we need to code the map reduce programming. So MR consists of the 2 parts. One is the map part, another one is the reducer. So first, after you code the file, should be Java program. Okay? Then you need to make the jar file. Okay? So Java archive file. Actually, each node has their own daemon program. Okay? Who really works on a computer? It's a process. Okay? So which means when you run your header system, not only the enabling HDFS file system, there are created processes, daemon processes. So, for example, this one has the naming node. Okay? Naming node process to coordinate entire system. Also secondary naming node process. So this one is a process, also this one is a process, also there is another one which is a job tracker. Job tracker is the process to coordinate the map reduce job. It can receive the request from the client. That is the job file. So WC, the job file, will be using this one as a request to the job tracker. Job tracker can be running on the master node, but it can be separate node in case it's a big header system. Then each node has the task tracker. It's a TT. That's it. TT. Not only data node, the process, each one has the task tracker. So there are 2 concepts. One is the job. What is the job? It's the project, entire project. On the other hand, task is a part of job. Okay? So one job consists of many tasks. Also there exists task attempt. Okay? Task attempt means sometimes this one is slower. So job tracker realizes the first data node is slow to compute. There is another node which is available, for example, data node 4, transfer block to this one. If not exists, then run the same program. So another attempt. Then if this one is the fast, discard the previous one, accept the result from the disk. So the number of attempt, okay? The number of attempt is sometimes much bigger, okay? But number of tasks, the task will be the same as what? The block. So this job will assign the task for each block. For example, if we have the 3 blocks for the food, that should be analyzed, that should be counted. At the time, task tracker 3, task tracker will be running. This is called data locality. Okay? They don't have to the transfer. So which means a task tracker this process count the word for only this block. This one count the word only for this block and only for this block. Something like that. So data locality. So task tracker will work so client first request a job to this one, and there's the file system. It's kind of shared file system, distributed file system. Who that use it for this distributed file system, they will read the data. Okay. Also, each demand process, task tracker, job tracker, naming node, data node, each process should have what? Java virtual machine. They are running on Java virtual machine, Java virtual machine, Java virtual machine, Java virtual machine. Okay? And they send the class object. This WC the jar file includes the class object base and client to first send such a compiled object through the Java virtual machine. Okay, then each node task tracker know what will be monitored. Okay, so that is the first initiating the job. So for example, client request a job to the job tracker know where the data nodes are distributed and are there. So client will send the object file to each node, and each node will receive the object file, then run the first mapping. Okay? So in your mapping program, what is the main role of the mapper? Mapper, main goal of the mapper is to read the file.
Yes.
Okay? Read the file as the input stream. Okay? If you are not familiar with the concept of stream, so you better read the Java stream or something like that, or the standard input and standard output. It's an input file. Okay? It's not like exactly same as the video streaming. Okay, but it's called the input stream. As an input stream, it will open the file, specific block, and from the block, it will extract a record. Okay, by following one. Input file format. So text, or sometimes it's integer, or something like we define text or whatever. The key should be writable, comparable object. It's not actually data type that you know. But sometimes we can, in general, we can say it's a data type. But it's not actually data type, but they are object file. Okay, object. So you define, or you can define, or you can use the existing given object. We will see a little bit details about the input file format. So by following the input file format, for example, in this case, we will use the input as the file. Okay, that is the key will be offset. Right, offset is in this case 0, and value is entire line until new line character. Okay, that is the new line character. This is one record. Then also, if you do not like what I want to from here is I'd like to extract for each word. Then you can further process depending on your business growth or algorithm. So for example, in your word count program, you actually separate by word, then assign one for each word. For example, the first line, I1. Okay, and M1, O1, student, 1, U1, and so on. And for the second block, you can do the same. Third block, you can do the same thing. It's the same object. Okay, this is the mapper. So mapper, how many mapper will burn on your job? The number of blocks. So always number, you don't have to specify. So this job tracker know how many blocks and where each block is located. And as contact this one, so the task tracker will run this mapper object. How do you know the mapper project? The mapper object? In your driver, you specify what is the name of class for mapper. Okay? Then, after each task tracker is done, what is the next?
Shuffle and sort.
Shuffle and sort. So, for example, this is a little bit tricky, the presentation, but don't be confused. So, output of this one. So, key and value. And key 1, key 2, and value 2. Something like that. This one has also key, value, sometimes 3. And this one also has key, value, like that. So this is the intermediate, the key and value format. There is a specific format of this one. Output of mapper is specified in the map. So that's the reason when you define, initiate, instantiate the mapper, you need to specify full input and output object data type. First two, key and value for input. The last two is for output of key and value that should be the same as input key and value of reducer. Because the reducer will receive this one. Before that, there is another additional step. That is shuffle and sort. Shuffle and sort means before they send the result of mapping to the reducer, okay, they sort locally. Sort by key. That is the reason key should be writable, comparable object. Okay? So writable, comparable. They can compare each other. So sort by the key. Is it unique? No, it doesn't matter. So concept of key in this, the head of map reduced programming is different from the primary key. Okay? Primary key is non-null and unique, but this is not. This is just a key. Yes.
Where they are sorted.
So then, based on key sort by the key and value pair will be sorted by key. For example, this is the I, this is the A, then
where are they sorted?
So locally.
Locally.
Yes, locally. That is actually key point. How we can make the map reduced programming faster. Okay? Before they send the data to the reducer, if the reducer receives a bunch of the intermediate key and value pair, it takes much longer time to sort the data. Why? They need to anyway combine T1, T1, T1. They need to combine later. Right? So before send such a data, why don't we locally sort the data, key and value? Okay? Then send such a intermediate data to the reducer. So where is the reducer running? Where? So running on data node also. So it will be one of these, but for your understanding, it's just diagram. Okay? We have data node, data node, data node. How many data nodes are needed to run the reducer?
At least
It's just one. If you do not specify any value, it will be one will be used for reducer. So reducer, what is the job of a reducer? For example, intermediate value of this one, in this case, we have 1, 2 up. Okay. Then after receive, it will be combined. So we sum up.
Yeah.
Who decide to sum up such a data? You,
Yeah.
in your program. Okay? They just follow the logic that you code. So if your logic is not sum, like the average or the whatever, you can do. So that is the benefit of the MapReduce program. You can focus on your business logic and algorithm. Yes.
So if the data is very big, only one node having a reducer can handle a very big amount of
Yes. So we will talk about that. So first is a default to this one. So each node should send the data like this. It can be sometimes a bother to receive this. So, for example, also we have the huge the processing and the reducer. Okay, not just the sum. You need to address. Also, for example, there is a word count. This one is the A to N, and this is the O to S. This is a T to Z. I'd like to do this one. So today we are going to talk about how to distribute the reducer job. So if you want to this one, at the time you need combine. Partition. You need a partitioner. Partitioner is a part of the mapper. So once they are processed, using the value of key, you can specify the specific reducer. It's a very useful for if I like to analyze the sum of the visiting customer by week of the day, like a Monday, Tuesday, Wednesday. So you can have the 7, the reducer. Then for each the week of the day, you can process some of the separate, or by region, or by category. Okay, at that time you can distribute the job of the reducer. Okay, that is the partitioner. Also, one more thing that we are going to discuss today is which is called a combiner. Combiner means if we need to sum up the data, why don't we sum up earlier? For example, there's 2 here. So intermediate format of this one is 1, 1 as an array interval data. Why don't we sum up earlier before we send the data? We can reduce not only the packet size, okay, network overhead, but also we can minimize the overall workload of the reducer. So combiner is the kind of small reducer. Okay, actually almost the same. So you can use existing the reducer class for combiner. Then this combiner is running on the locality after mapper before send the data to the reducer. So today we are going to talk about the partitioner and combiner too. Then after this one, what about the input and output format of the combiner? It's the same as the reducer. Okay. Then the reducer output of the reducer will be stored at HDFS file format. But these are not separate nodes. This is just for your understanding. All of them are data nodes. Who decide your naming node and job tracker will assign the job based on the locality of the data and resource. That is the reason resource manager in the MapReducer is very, very important. Otherwise, you need to take care. If you already took the multi-part programming or pair programming, so your algorithm should be changed. You need to take care of how to balance the workload and whatever. But because of the resource manager, you don't have to worry about. Instead, you can focus on your logic and the algorithm. Yes.
What does the partitioner do again?
We will discuss today. Idea is partition the job. So how to distribute the job to the reducer. Any question?
Excuse me,
Yes.
so the shuffle and sort just like recognize the
Which one?
shuffle and sort.
Yeah, shuffle and sort.
Just recognize the keys and value.
Yeah, using key sort. The key and value pair by key. Okay, before you send the data to the reducer.
So it doesn't. I mean, it doesn't already happen on the recognized and the note for the.
No. So to recognize the node for the reducer, you need to code additionally, partitional. Otherwise, it will be go to just one reducer. Okay? Okay, so today we have a lot of things to discuss. We need to complete all the part of the map reduce. Also, I'd like to introduce some map reduce pattern. Okay, what kind of job? I cannot explain all detail. I'd like to show only one of them, but it's your job to see and start by yourself. The rest of them is 200, more than 200 pages of slide. Okay. Also, it's actually the summary of one book. So this I will just introduce them, and also followed by the Hadoop installation. Okay. First, we are going to talk about the streaming, the map reduce streaming. All of these are based on what? Java program. Okay, so each node has the Java. Each process has a Java, their own Java virtual machine, and you can implement the map reduce programming using Java. Then after you compile, you can make the Java archive file. This Java archive file, it's not runnable. You don't have to make the runnable Java archive file. Sometimes if you download or if you make a runnable Java file, you can double click, then run Java application, right? But it doesn't have to be the runnable one. Hadoop will run, okay? Hadoop command. When you run this one, how can you run? Hadoop job, then class main class one, right? Main class object name, then using this information, this class file sent to the tracker, job tracker, and the task tracker. Then each task tracker has their own Java virtual machine and running. It's based on the Java. What if I do not know Java? You need to know. You program. But that's the problem of the industry. It's okay for students because you can learn the new language, new environment. But in industry, their life, the program life cycle is very short. So there's no time to train all the employee. Like you have the 1,000 employees, so they do not know the Java. So you need to train. It takes a long time, and the competitor will launch the new system, and so that's a problem. So to address that problem, there are map reduce streaming. Because if you see this one, Java is act on what? Act as interface. Okay. What if we implement such a logic? The important thing is input and output formula. So you specify the object name, data type, text, or the file stream, whatever. We will see it a little bit later. But if we can use the different interface, also different algorithms, that's it. Inside, there's a map reducer. Even though they are implemented based on the Java, as long as you can communicate, interface, it's okay. So, based on this idea, Hadoop support other program languages, which is called the streaming, like the Ruby. Anyone who uses the Ruby, it's actually made by one of the engineer in Japan. It's a very simple language, and probably you know the Python and the Perl. Python is right now very useful. It's very easy to learn. I never learned the Python, but easily can understand. It's a shared programming language. Very powerful. You can use the existing API. And you can do whatever you want. Perl, you know the Perl language. Actually, Perl was developed by who? I cannot remember the name of the guy, but who was Unix administrator. So when he managed the Unix system, he needed some for the administrator, usually network administrator, Unix administrator, database administrator, they don't require very high-level program languages. Instead, they need the system program language as well as shell script. Okay? So same for me when I was an administrator. At that time, the existing shell script languages are convenient but not very powerful in terms of management, system management. So he developed something module, okay, for managing and monitoring the system. That is actually part. Then it's extended for the variety of the application. So we are going to use such a language. It can be basically any language as long as it can have the interface, input and output. Basically, in Unix environment, there are three streaming interface. One is what are they? Standard input, standard output, and standard error. What are they? It's a file descriptor. So actually, from the Unix perspective, I'm not sure Windows, but the Unix perspective, it's the same thing for Windows, I think. What is a file? File is nothing but ID number. It's a descriptor. Probably you learned in your operating system. When you create the file using FOP or whatever the API, the name of the API, you can when you open the file, the file ID will be assigned. And each file has the file name. No, file name is for your understanding. File descriptor will be created. This is the data structure. Even though you create the foo.txt file, it's for your understanding. Because you cannot understand the very complicated 0x, f, the a, the 0, 1. It's very complicated. Okay? It's a high level. The abstract, it's only for you. So instead, file descriptor will be created. As a default, when you create the process, it will create 3 file descriptor. One is standard input as an input. You can type. Okay? If you type, then it will go through this one. Standard output, any output of the process will be standard output. In case of an error message, it will go to the standard error. There are 3 interfaces are created. So we are going to use any processor. It doesn't matter. Ruby, Python, Perl, and Fortran, COBOL, doesn't matter. Any program language will create a process. Each process should have standard input, standard output, and standard error. We are going to use for this as an input and output of the process. Input will be what? Data HDFS. Output will be this one. So that's the idea. So advantage of the first one, we get the example of the word count method. This is a word count method for using Perl. I'm not sure whether you understand this symbol, sharp discrimination. No, understand. It specifies the script language type. If you want to use the Perl, it should be Perl. And if you are using the Ruby, it's Ruby. If you want to use a C#, it's a C#. If you want to use AWK, it will be AWK. Okay? So, using the first one, you recognize this is a Perl language. Then, from the standard input, Okay? So from the standard input, get rid of any new line. Then for each new line, you split by the word. Okay? You create an array of word for each word. So you can assign the key and value. That's it. Very simple. So if you are familiar with the Perl, so you can implement the mapper using the Perl. Yes.
So it's gonna be the file. So then what's the input or where we gotta put
So
that?
we will see. Okay. Then how can we run this one? Using the Hadoop command. Hadoop jar. Okay. At that time, we are going to specify the map script.pl. So Perl language. Perl language reducer. Then these actually files should send to like the object file will be transferred each Java virtual machine. This file will be transferred. Then input and output directory will be input of this mapper. As you specify the input and output in your head.jar, so do you remember the command that you did last time? What? Hadoop jar main object and input and output. Input and output. This input will be standard input of map. Where? Inside MapReduce system. You don't have to worry. Right? So just specify this one. This is the way. I'm not expertise on the other program languages. So if you want to use the Perl or other program languages, you can try. There are a bunch of the tutorial for the Hadoop streaming, so you can try. So definitely benefit. This is good for the non-Java code who are developer. Okay. So you can reduce the development time, right? And also another benefit of this one is, for example, Python is very good for the data analytics, or the Perl is good for the visualization, and Ruby is very simple. And if there is any additional library, you don't have to implement. You can just call that API using that one, which is not in Java. Which is, even though there is, if you do not know how to use that, you can try the Java 3. Problem? Performance. Anyway, the MapReduce system is based on the Java. Definitely, Java object will work very well. That fit to the this MS system. When you are using this one, anyway, it should be the transfer, like the for example. Current operating system is based on layered approach. This is kernel. This is the system like whatever and interface. They need to communicate. Even though it's easy to manage and develop in terms of performance, each layer you need to communicate. If you implement the system as a streaming API, from other program languages to the Java, the MapReduce, they need to communicate. It's a communication overhead. So roughly 20 to 30% performance degree. If your performance is critical in your job, you need to think about the Java. Okay? And sometimes, I do not know the why, sometimes when you are using the streaming API, it will fall. In other words, it will create too many processes. It's kind of bug so far. So it's called fork bombing, or the process bombing. It creates a bunch of process. What does that mean? Bunch of process. So waste of resource. Okay? Yes.
Which one do you prefer?
I cannot say because I never used the other streaming API. I only use the Java. So why don't you try? Okay? It depends on. Okay? If really critical for your performance, Java is better. But otherwise, if you already know the Python, why not? This one is the easy.
You can use like Python to get data.
Yes.
Well,
You don't have to worry about a bunch of Java library object and the compile. So you don't have to. It depends. So in your project, doesn't matter whether you use the Java or the streaming API. Okay? It doesn't matter. So how streaming works? It will be interface, kind of interface between. So we will see the details, the format of that later, but it's basically the interface. But some of the functionality are limited in the streaming API. For example, separator, or for example, it should be key and value, only the tab and new line character. Okay. Otherwise, if you have the different separator, you need to speculate, or you need to specify the different separator and also it's usually one line for standard input automatically, which means a new line character will be used. So in your data file, there is no new line. The character, it will consider one big line. Okay. So at that time, you better use the Java programming to cut by breadcrumb. Okay, using especially the character or the indicator. But in because they are using standard input and output, they will consider new line as a record automatically. But in Java, it is considered even the interval is array, but this is not. Which means, so for example, A111 can be done in Java, but streaming it should be 1, 1, 1 always. Okay. So this is the way to run. Sometimes the student are confused. There is two types of the name of that. The first two is to specify name of mapper script and the reducer script. And this file means the file should be transferred from client to task tracker. Actually, usually they are same. Okay. Also, to handle the bunch of things, the input and output work, so you can use the other Unix command or Unix shell languages, like the AWT is very, very powerful shell script to manage the two-dimensional data, and grep you already see to pick up the specific keyword, and SAD is very, very powerful. It's a regular expression. So you can handle the work using SAD very, very nicely. And WC is just nothing but word count, the command. What about the Eclipse? I can use the Java only through the ID. You know what is the ID? It's a development environment. There are a bunch of the different ID, like the Eclipse. What else? NetBeans and even the Windows environment, there are a bunch. So if the header support Eclipse ID, so many of you guys are familiar with Eclipse at the time, you can use it. It's from IBM, right? So you can use the Eclipse as an ID. So you can do whatever you want, except execute the jar file. You can create up to the jar file, but you cannot execute the jar command. Why? Because this jar file is not runnable. Okay? Instead, it will be transformed, executed by the header command. So, if after you build the jar archive, you need to type header jar on command line interface. However, I heard that I never used. There's some program or library add-on to execute the header command. Okay. But I never tried. So this is the interface. So How many of you ever used the Eclipse? 1, 2, 3, 4, 5. So if you see the Explorer left hand side, you can see the package that you create. So you will import such a package that you are going to practice throughout the semester. Okay? So that includes average word length combiner and counter for. So for example, word count over here. Then it has the probability 3 Java file. One is the driver, another one is mapper, and the other one is the reducer. Then after you code this one of the different first time when you are using the Eclipse, probably you will be weird to use the Eclipse comparing to the other IDE. What is that? Did you compile the Eclipse? Or did you build or something? No, you don't have to. Unlike the other, like the Visual Studio, you need to build, right? After you the code. But here you don't have to. Why? It's so